Okay, this is the part we've been waiting for. The KNN model itself. How does it work? How does it classify? How will we use this to classify the flowers? So basically, the KNN model, in the most simplest form, it's just measuring the distance of data points. So I'll go here first and I'll say focus on the little circles. Focus on the little circles. It's similar to what we looked at up here, similar to what we looked at up here, and then we're bringing a data point. Now I'll go back again. I'll try not to make it too confusing. So just focus on circles. This is a scatter plot we're looking at, and the X is a data point that the model hasn't seen before, and we're trying to classify it using the model. All these data points here, they have been trained, they've been used to train the machine learning model. That's how the training works. And the machine learning model knows what category these belong to. So, say for example, this is C1 represents Setosa, C2 represents Virginica, and C3 represents Versica. And then this, for this example, there's four. Obviously, we're working with tree, but just for the example, we'll just say this is like a rose. Now we brought a new data point, and then the y-axis, for example, say that's sepal width, and the x-axis is, uh, for example, sepal length, right? And then we have data, and they fall under this, like this data point falls under this sepal length and this sepal width, for example. And now we've brought in a new data point that falls here. So, well, thinking about anything, if you had to guess, because it works by essentially KNN, K nearest neighbors, if you had to guess, you would just say, well, even looking at the red, you'd say this belongs to C1, which I think I said was Setosa. Straight off the bat, you're saying that's likely a Setosa. And that is all the model is doing. It's classifying based on this. But to get into more detail, there's a hyperparameter where you can adjust the number of neighbors, and we'll go into more detail on that as well. So in this case, 1, 2, 3, 4, 5, 6 neighbors are used here. And now it will go by the distance between its nearest neighbor. So it's used 6, and the closest to X seem to be in C1. Now it's got one in C3 and one in C2, but it's gonna vote a voting structure because it's got four here, so it's more likely to be C1 than anything. So it will say when the machine goes to classify this, it's gonna classify it as C1 Setosa. And now there's different ways of measuring the distance. This is more detail that I think is required. And Minwaski is basically the between these two. Like it takes into consideration these two to measure the distance. But why it's defaulted, but why you might not always use it? That's a question I asked. Is because it's more complex to run and it can be harder to explain and it's harder to understand as well. So that's why you might want to use this, which is the numeric data. This for more like numeric data, and this is for more categorical data classification, which is what we're working with. But this is default, and you can tune this to get better results. Or you can use either one of these if you're not happy with how your machine learning model is working. It's something you can tune to improve your machine learning model. So I hope I've explained that well. Here's some data. Determine the K selection depends on your data and project requirements. So this is the number of Ks you want to use, the number of red lines. You don't want to use too little or too many. In this case, we're going to test between 1 and 9 Ks to see which one gives the best predictions. It's a hyperparameter that you tune, calculate distance between the new input and all the training data. As with K selection, distance function also depends on the type of data. Sort the distance, determine the K nearest neighbors based on the minimum distance. This has the smallest distance to these, plus the Ks, gather the categories of those neighbors. So the neighbors here to this are in C1, and then determine the category based on majority vote, determines that it's going to be C1. And that's how K nearest neighbor classifier is working. And now we'll go into how we're going to run it in Python. That was an explanation of how it works. I think that can be a separate video or a separate section. So I'll stop it there.